In this lesson, we're going to introduce scatter plots. And a scatter plot is just simply a graph, like we saw in the last video, where the x and y values represent real-life data. And we make a scatter plot to try to understand the relationship between the two sets of data. And so here we're looking at temperature versus chirp rate of crickets. Okay, it says that biologists have observed that the chirping rate of crickets of a certain species appears to be related to the temperature. And so we might want to have a visual representation of how those two things relate. And so what we have is each row in this table represents a particular observation. So for example, a scientist might take a temperature reading of 50 degrees outside and then count that a particular cricket chirps 20 times per minute. Okay, and so that gives us a pair of numbers that go together. And so since it's a pair, this is really just the same ordered pair that we've already seen. Okay, so be the ordered pair 50, 20. Now, we're not going to get too much into this, but the reason I chose temperature to be the x and chirp rate to be the y is because it's convention to make the x value the independent variable and the y value the dependent variable. So, of course, the chirp rate of a cricket would probably depend on how warm or cold it is outside, right? So, since it depends upon the temperature, that's why it's the dependent, and that's why I made it the y value. Again, we're not going to focus on that too much, but it's just something to be aware of, and you will run into that a lot more as you continue on in math. So we need to make a graph here, and so the first thing to do is to label your axes. So we already decided that temperature would be our x value, so I need to say so down here. I need to let the person reading my graph know that that's what the x-axis represents. So you should give a word description of what it is, temperature, and then tell the reader how you're measuring it. And so we're measuring it in degrees Fahrenheit. We'll do the same thing here with our y value. And so what we have is chirp rate. So we'll write that up the y-axis. And how are we measuring that? Well, that's chirps per minute. So I should say so. It's okay to abbreviate, of course. And then the other thing we have to do is decide what our scale is going to be. So are we going to count by ones? Are we going to count by fives, by tens? How are we going to count? And then secondly, where should the smallest, what should the smallest temperature value be on our graph? What should the largest temperature value showing be? So first of all, we have to understand that the place where the x and y intersect each other is always the origin. This is always 0, 0. Okay? And if we look at chirp rate, let's look at the chirp rate first. So that would be our y-axis. We have quite a range. We have anything from 20 up to 210. Okay? So looking at this, to get from all the way up to 210, if I used spacing of 10, then I would need exactly 21. I would need exactly 21 notches here to get all the way up to 210. And it looks like I do have about that many notches. So what we're going to do is we're going to count by tens, but so that things don't get too cramped, I'm only going to label every other notch here. So I'm going to start at 0 here. This will be 20. This will be 40. And so I'm still going by tens because it's 10, 20, 30, 40, but I'm going to only write the 20, the 40, so that we don't get things too crowded. Okay, so that looks to work out pretty well. Now for temperature, we have from 50 and looks like up to 90 is the highest. So we don't have quite as wide of a range, so we probably don't need to go by 10s even. But notice that we're starting at 50. So I don't think it makes a whole lot of sense to start here at 0 and then have your very smallest x value be, somewhere way up here. So what we're going to do is use this little trick where we can, right after the 0, I'm going to put a little break in the graph just like that. Okay, and this break indicates that yes, this is still x equals 0, but the break indicates that there's an interruption, and when we pick things back up again right here, that this is going to basically represent whatever we want. So I think what I'll do is I'll make this value right here 50. Okay, and then I think it makes sense to maybe count by 5s every 2. So if that's 50, maybe I can make the next one 55, and then the next one 60, and the next one 65, and 70, and I think this is going to work out just fine. And then we're up to 90. We'll do one more for good measure, get up to 95. Okay, so remember, if you're going to skip a whole bunch, that's fine, but just put a break in there. Some graphs, instead of a break the way I made it, might look like this. Might put like 2 bars there, and that might indicate that that's 0 and that's 50. Okay, so if you want to make the break like that, that's fine, but just make some sort of 2 lines there, or a kind of a squiggly line to indicate that it's skipped a whole bunch and that the scale from here to here is not the same as the rest of the x-axis. And now finally we can graph our ordered pairs. So we have 50, 20, so that's an x value of 50, a y value of 20. So that goes right there, the intersection of 50 and 20. 55 and 50, so we're at 55 and then we're going to go up. Here's 40, but we got to go up halfway between 40 and 60 to get 50. Then 60 and 80, so here's 60, here's 80, 65 and 90, 70 and 110, puts us right there, halfway between 100 and 120, 75 and 140, puts us about there, 80 and 170, oops, too far, there we go, 85 and 200, there it is, and then finally 90 and 210, so that puts us right there. And so the nice thing about this is, just looking at the table, you can kind of see that as temperature goes up, chirp rates go up, but this gives you a really nice visual of that. You can see as the temperature increases, the chirp rate is also increasing.